All right, so we got to here. Now we know the object's one time of flight. So here's its time of flight, right? Which we used to sub in. Let's think of object 2. It waited for 2 seconds, so it gave the other one a head start, but it landed at the same place at the same time. Therefore, it must be quicker. So the second object's quicker by 2 seconds because it waited 2 seconds. So its time of flight, let me put it here, its time of flight must be 2 seconds more than this. Less, sorry, I said more, less. Must be 2 seconds less because it's faster. So if we do that, if we want to make it a nice exact, we could just times 4.9, we could double 4.9, couldn't we? So that's 9.8. So that can be its time of flight. This is our blue object, is our second object. And the other thing I don't think we need anything else. So we've got the x value and the y value when it lands. So that x value and the y, obviously the y value is 0. And the x value is 100 root 3 on 4.9. We're given that in case we couldn't do part 1, we can still do part 2. So now I've got that information. I'm going to rub this bit out and use the same equations of motion. It's just we have a different value velocity, and so we have a different v and we have a different angle. Clearly angle. There's my y there. All right. So what we do know though is the time of flight is up here. So if I sub that time of flight in, and also I do know my x value. Let's sub both those in and see what we get. Because here for our second object, which has gone 2 seconds later, we want to find its initial velocity and its angle of projection. So I'm going to put in everything I know here. So I've got 100 root 3 on 4.9. I don't know it's v, but I do know it's t. So I've got v, t, all that t business, and I don't know its angle. So I've got that as one of my equations. And let's leave that one there. If I look at my y equation, so if I make my y value 0, because I'm subbing that point in, I won't rearrange too much at the moment. So I've got 4.9. I'm going to run out of room. So I've got that t value all squared. I don't know my initial velocity. I've got my t value and times sine theta. All right, pretend that looks nice. Now, if you have a look, there's a section. I want to put them together because I want to solve simultaneous equations where there are two unknowns. V and theta are my two unknowns. Now, if I look carefully, I can see a nice way to do a substitution because they've both got, I'll rearrange this y one first. So if I put the 4.9 part, so this first term on the other side, I have 10 root 3 minus 9.8 on 4.9, and that's squared, and then I've got v blah 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 sine theta. All right, and so if I made that so that's my second equation, and up here is my first equation. So what I could do is take my second equation and divide it by my first equation. Because these ones, now the left-hand sides both have the v, in this case cos theta, and v bracket sine theta. So it looks kind of nice, like I'd get rid of the v's, which is what I want to do. So I'm taking this equation and I'm dividing it by this equation, because in that way I will get a tan theta, right? So what I end up getting is, if I divide v by v and the bracket by the bracket and sine theta by cos theta, I will get a tan theta on the right hand side. On the left hand side, I'm dividing, the bracket is not quite repeated, is it? It's just ugly. Basically, it's ugly. So I'm going to put maybe that in my calculator and divide it by that and get some answer. Some weird brackety answer. So when I do that, it's actually going to be 10 root 3 minus 9.8 squared on, I'm hesitant, but I think that is correct. All right, so I have done it, but just straight from the calculator. So when I inverse tan, I get 18.1 degrees to 1 dp. So there now I've got my my angle of projection. And then, of course, which one would you sub it in to find your initial velocity? Probably the easier one, or the one with less squares, less terms originally. And if you sub it into this one, we're subbing it into here, into the angle here. So it's now cos of 18.1 degrees there. So we'll take that whole term once we've subbed it in, and we're going to say 100 root 3 on 4.9, and we're going to divide by 10 root 3 on 4.9 minus 2 times cos 18.1 to get our velocity. And our velocity should be 24.2 meters per second. That's also to 1 decimal place. All right, hopefully that helped. So we were looking for the initial angle of projection and the initial velocity for that second particle.